Welcome back to the Big Dog Podcast, powered by Kaishan USA, where industrial air meets unfiltered, straight-talking conversation. I am Jason Reed.
And I am Lisa Saunders. Today we are breaking down compressed air energy efficiency, the tech, and the real challenges plant managers face on the shop floor every day.
You know, if you walked onto almost any shop floor right now and pointed at the biggest, most aggressive electric motor in the entire facility, 9 times out of 10, it is not on a massive saw or a giant conveyor. It is sitting right inside the main air compressor.
Right inside the air compressor. And people look at the purchase tag on those machines and think that is where the real money is. But a classic U.S. Department of Energy study showed equipment and installation is only 12% of the total lifetime cost. 12%.
Yeah, 12%. And maintenance is another 12%. The other 76%? Pure electricity. That is why in facilities like food processing, compressed air can easily swallow 15 to 30% of the entire plant operating bill.
76% on power alone. So when you are picking a compressor, you're not buying a shop tool. You are basically signing a long-term power contract.
Exactly. And that brings us to how these different designs actually chew through that power. Take piston reciprocating compressors. The standard commercial models most folks start with, they have a major physical wall, a 50% duty cycle limit.
Wait, 50%? So out of an hour, it can only run
30 minutes. 30 minutes on, 30 minutes off, just to keep from overheating the mechanics. So to get the actual usable air your plant needs, you end up having to buy a much bigger horsepower rating than you would with other types.
So you inflate the horsepower just to make up for the cool-down breaks. Whereas a rotary screw air compressor, that is designed for a 100% duty cycle, right?
100% continuous flow. The interlocking helical rotors just trap ambient air, shrink the chamber volume, and pump it out. And rotary screws deliver their peak energy efficiency when they are running right up close to full load. For most industrial setups under 400 horsepower, the rotary screw is pretty much the undisputed champ.
Under 400 horsepower, got it. But what happens once a facility pushes past 400 horsepower? That is where centrifugals enter the picture, right?
Right. Centrifugals use high-speed rotating impellers to move massive volume from a relatively small footprint. They can be super efficient above 400 horsepower, but there is a catch: the part load trap.
The part load trap, meaning when plant demand drops below full throttle?
When demand drops, a centrifugal cannot just turn down easily. To prevent surging, it has to vent excess compressed air right out to the atmosphere. You are literally blowing manufactured pressure into thin air while the electric meter keeps spinning.
Blowing money straight into the air. That is a massive penalty if your air demand swings around during a shift.
Huge penalty. In fact, between 400 and 600 horsepower, a 2-stage oil-flooded rotary screw often beats a centrifugal on total cost of ownership simply because it handles those demand swings without dumping air.
Well, let us talk about those 2-stage rotary screws for a second, because that is where the math gets really interesting. By splitting the compression into 2 separate steps, you are extracting way more work per kilowatt hour, right?
Yeah, you are looking at 15 to 20% more airflow for the exact same power draw. Historically, manufacturers only built 2-stage units starting at 125 horsepower and up. But companies like Kaishan offer 2-stage models down to 30 horsepower now, so even mid-sized shops can grab that efficiency boost.
15 to 20% more CFM at 30 horsepower. That pays back the price difference super fast when electricity is 76% of your total cost. But okay, Jason, what about plants that cannot risk a single drop of oil in their airstream, like pharmaceutical or electronics or food packaging?
The oil-free tax. See, in an oil-flooded rotary screw, the oil seals the tight spaces between the rotors and pulls out compression heat. In an oil-free machine, you lose that liquid seal and cooling medium. The rotors run hotter, air leaks back past the rotors, and the thermal efficiency drops.
So oil-free actually costs more to run because the physics of sealing without oil are just tougher?
It is a physical energy penalty, plain and simple. Modern units like Kaishan's 2-stage oil-free design have to use specialized intercooling and rotor coating engineering just to claw back those lost kilowatts.
Man, that is why you really have to know your exact air quality requirement before making assumptions. Now, what about plants with fluctuating demand? You mentioned variable speed drives earlier.
Yeah, VSDs are huge. According to data from KGI, the Compressed Air and Gas Institute, adding a variable speed drive can slash energy consumption by about 33% in the right setup. KGI is really the unbiased authority on compressed air performance, and their testing shows matching motor speed directly to real-time air demand. Stops the compressor from constantly running at full tilt and then idling under load.
33% reduction. That is a third of your power bill gone. Plus, you get soft starts and avoid rapid cycling wear on the equipment.
Right. But remember, the machine itself is only one part of the puzzle. You can buy the sleekest VSD unit on the market, but if your controls are misconfigured or your plant header pressure is set 10 psig higher than necessary, you are throwing money away. Pairing a baseload machine with a dedicated trim unit under a master controller can keep system pressure locked within plus or minus 2 psig.
Plus or minus 2 psig instead of letting pressure bounce all over the place and cascading multiple machines on and off. And fixing air leaks. I feel like people always forget how much energy is wasted through small air leaks in the piping.
Leaks are the silent energy killer on the shop floor. That is why requesting a full energy assessment and audit before you ever order new iron is usually the smartest move a plant manager can make.
Because at the end of the day, matching the system setup to your real-world demand profile matters way more than just chasing a single efficiency number on a spec sheet. That 76% energy cost means system design wins every single time.
Every single time, Lisa. All right, that is going to wrap it up for us today on the Big Dog Podcast. Thanks for tuning in, everyone.
Catch you all next time.